Hello everyone, today we are going to talk more information about ANOVA. As we know, ANOVA is an analysis of variance. An ANOVA hypothesis test determines if several population means are equal, and the distribution for the test is the F distribution with two different degrees of freedom, and the F value is equal to the MSB over MSW, which also followed by the F distribution. And when calculating the ANOVA table, we also get three assumptions. First of all, each population from which a sample is taken is assumed to be normal. Second, each sample is randomly selected and independent. Third, the populations are assumed to have equal standard deviation, or we call variance also. So we can easily build up the one-way ANOVA by calculation or by the Excel files, but we may not consider that why ANOVA follows F distribution. In the following video, we would like to introduce the reasons here. First of all, let's have a brief introduction with you. Since ANOVA is talking about the ratio between two variants, one is the MSB and another one is the MSW. There are two variants. And we know that the variance is followed by the chi-square distribution. If you do not know about it, it doesn't matter. I will explain it deeply. The variance, calculation variance, is built up from the mu. We take the average. The variance is talking about each element, and we compare it with the mu. And during this process, we know that the sample we choose is followed by the normal distributions. Okay, now let's get into the main part. First of all is the average. We also call it mean. And we can say mu equal to the x bar, which equal to the summation of all the elements and over the numbers of those elements. And from our previous assumption here is talking about each population from which a sample is taken is assumed to be normal. And by the central limit theorem, we know that when n getting greater and larger, here greater than 30, let's say, and our sample will follow the normal distribution, which means they will approximate to the mean. We get the first idea about the mean. Okay, then is the variance. Since the variance is taking the difference from each sample and the mean, when I add those difference together, we may get another result which is equal to 0. Since, example, mu here, and if I get x1 is here, we may get a positive distance here. But if I have a number, say S2, to compare with the mu, the result we get may be negative. That is the result. So if I add those difference here, we may get a 0 result. Therefore, we need to enlarge the scale and make sure all the difference here is positive. So we get a square here, a square. When I take the square, we can measure the difference here is positive. Since the sample we choose is followed by normal distribution, after we take a subtraction with those kind of numbers, and we also take a square on it, then the F distribution, the graph of the F distribution may change. Then we'll take a look what kind of change it may have. First of all, from the normal distribution graph, we can see that it contains two parts. One part is the negative sign and one part is the positive sign. And if I have a number subtract with the mu and I get another result, it may have positive or it may have negative, so it may have different results in the graph. After I take a square on it, if I take a square on this graph, what we may see, it may become. Also, if I take a square with the negative sign, it may same as the result of the positive sign. Then it will double the shape. The shape will become like that. However, since our calculation here is talking about the difference, if I get zero number here, then the distance will become 0 since there is nothing. Therefore, we may change the starting point is from the origin here. So the graph may change a little bit like that. That will be our new graph, new result. Let's talk about the new result. This one we call it chi-square distribution, which is the variance followed by, and as we can see, at the starting point is come from the origin here, and the origin is mean that there is no any numbers, and the comparison of those numbers is 0, so we're starting from zeros. When the number get greatest, we can build up a lot of results here, and finally we can get so kinds of beautiful graph, and we call it chi-square distribution. So we call variance is followed by chi-square distribution. Remember, the chi-square distributions always be positive, since we take a square on the difference. So this part, no matter the difference is positive or negative, after we take a square on it, it should be positive, which is greater than or equal to 0. So the variance of the whole distribution should be positive. Okay, after we know about the variance, then we know that in our ANOVA calculations, one of the final part is the MSB over MSW. Since MSB is a variance of the vector, and this one is the variance of the error. So when we compare about two variants, the graph or the results may not follow by chi-square distribution, since the ratio may change. So let's talk about the F distribution. The F distribution is talking about the two variants, the ratio of two variants. So if the F equal to 1, which means the MSB equal to MSW, and we may think that is same graph with the chi-square distribution. However, if F is less than 1, which means the MSB is less than MSW, then the graph may be changed. And also, if F greater than 1, which means the MSB greater than MSW. Therefore, the graph may change and we may get different results. So we cannot say that the ratio with those two variants also follow chi-square distribution. So we get another stuff for it. We call it F distribution. And you can see that there are different curves here, since the ratio may change and the numbers of the numerator, the degree of the numerator and denominator are different, so we may get a different result. So we can take a look about this F distribution. Okay, then it's the fact about the F distribution. As we can see, the curve is not systematical, since they may have different results, but it always gets to the right, since it should be positive. And also, there is a different curve for each set of degrees of freedom, and we can see the previous slide, and we can see that the N and M are talking about the degrees of freedom with the numerator and the denominator, and they may represent in different curves. So the difference of the F distribution may differ. Third, the F statistic is greater than or equal to 0, as we mentioned previous. The F is talking about the ratios of two variance, and the variance are always positive, since we take a square on the difference. Therefore, our F value finally should be greater than or equal to 0. And finally, as the degrees of the freedom for the numerator and the denominator get larger, the curve approximate the normal. That's we call the normal curve, normal F distribution. Okay, now let's have a summaries about these videos. In this video, we talk about the basic concept of ANOVA, and we also make 3 assumptions of what ANOVA should have. Also, we're talking about why ANOVA follow F distribution. Since ANOVA is talking about the ratio about two variants, and the variance is computed from the mean. So as we know, the mean are followed by the normal distribution. After I take a square on the graph of normal distribution, we can see another beautiful graph. We call it chi-square distribution graph. And once we know that after we compare two variants, the variance of in the numerator and in the denominator may differ, and the results may have different kinds of curve. So we call another graph called F distribution. And we know that the F value is equal to the MSB over MSW in the ANOVA case. That's the whole picture of these videos. Hope you can have a better understanding on ANOVA and why ANOVA follow